Hi, I'm Miss Hearn. Let's get started. And if you find this video helpful, please remember to give it a thumbs up. That helps other students to find the video. Speed of a rocket. It says at t seconds after liftoff, the height of a rocket is 3t squared feet. How fast is the rocket climbing 10 seconds after liftoff? So are they asking us for an average rate of change or an instantaneous rate of change? And how can you tell? If they wanted to know the average speed, they would have said, what's the average speed of the rocket between 0 and 10 seconds? But it doesn't say that. It says, how fast is the rocket climbing 10 seconds after liftoff? That could be rephrased as at 10 seconds into flight. So it's a little subtle in this one, huh? It's a little harder to interpret. They're not saying between 0 and 10 seconds. All right, so this is actually asking us for an instantaneous speed at 10 seconds. Or another way we could say that is the derivative at 10. So in other words, if I define the height of the rocket, which we often, I know it's a little confusing, but when we're talking about position functions, for whatever reason, we use s as the position. I know you're going to want to think that's speed, but it's not speed. The position at time t is equal to 3t squared. So when they ask us for the derivative at 10, they're asking us to find s prime at 10. Okay, and how do we define the derivative? It's the limit of the difference quotient. So s prime of 10 is going to be s of 10 plus h minus s of 10 divided by h. Oops, sorry, bad teacher. Limit of that. What's it called when it's not got the limit? Without the limit of the difference quotient, it would just be the average speed over an interval. When it has the limit, that's the derivative, that's the instantaneous speed. So let's go ahead and evaluate this. Actually, I'm going to give you a minute to do that, and then I'm going to send out a survey and see what you got, okay? Okay, I'm going to ask you this question in two parts. The first poll is just to find s prime of 10. So evaluate the limit of the difference quotient, and then I'll send out another poll to ask you for the units. The most popular choice was C, which was 60, and that is correct. So let's look at how we get that. All right, so we're going to take the limit as h goes to 0 of s of 10 plus h minus s of 10 over h. That means, remember, the function s of t is 3t squared. So we're going to plug 10 plus h into that, which means we need to square it. Be careful here to FOIL that out. And then distributing, the 300s are going to cancel. We're going to get 60h plus 3h squared over h. Dividing each term by h, we're left with 60 plus 3h. Plugging in 0, we get just 60. Okay, so now we're going to do part 2. I'm going to send out the poll. I want you to select the units. All right, what would the units be? What is it that we just found? If you're not sure, it's okay to just take a guess. Just want to see that you're thinking about it. Remember, the difference quotient is a formula for slope. And the units on the limit of the difference quotient are still the same as the units for slope. So what is slope? Slope is a change in the y over the change in the x, right? Rise over run. So in the case of this function, that's going to be change in the function values s, which are the position, which is measured in this case in feet. And then the change in the time in this case is measured in seconds. So this is just going to be feet per second. So the answer is actually D. Remember, feet per second is a velocity or a speed, right? And that's what we were asked to find. The instantaneous rate of change, or the speed at that moment at t equals 10. If you found this video helpful, please give it a thumbs up. That will help other students to find the video.